Hi Math 2 students, this is Mr. Flynn. Just want to pass along some information to you. First off, if you go onto the Canvas websites, not only you'll see are the assignments and all that, but what you'll start to see is some learning objectives for the week, all right? And so with that said, our learning objectives, I think this week, if I got it straight in my head, we're going to do greatest common factoring. We're going to be solving for x using factoring. And remember, we're solving for x are just the x-intercepts or the solutions or the zeros or the roots, whatever they want to call them. And we'll go over that throughout this week. And then we're going to start to simplify radicals. And that's going to be not a brand new topic, but it's something that we haven't done all year. So it's been a while probably since you've seen any of that, if you have seen any. And if you haven't, we're going to start pretty simple and work our way up. So you notice here I gave you some notes on factoring, okay? There's a couple things. Number one, step one, we have to factor out the greatest common factor. That's number one all the time, all right? Don't ever do anything different. Always look for the greatest common factor. It's not always going to have it. Matter of fact, plenty of times it's not going to have it, but you got to look for that. Then we have to identify, is it a binomial, 2 terms? Is it a trinomial, 3 terms? Or it is a polynomial of 4 terms. Those are the 3 that we're going to be seeing all the time, okay? If it's a binomial and you've already factored out the greatest common factor, we look for that difference of squares, and we just saw a few of those last week, okay? We'll probably see a few of those again today, all right? And we'll talk about that. So a difference of squares is when you have something squared like x squared minus another perfect square, 25. That can be factored. If you remember, we'll have like x squared plus the 0x term minus 25, and now you can do, your factoring, okay? I just wanted to say that real quick because that's what difference of squares really is. It's a difference, subtraction, of perfect squares. X squared and 25 are perfect squares, okay? We'll practice that a little bit later. Then the trinomial. We talked about this, but this right here, you really have to commit to memory. You just have to get used to it. If it is a trinomial, first check the sign of the last term, okay? If the sign of the last term is positive, both the signs of our factors that we use are the same, okay? If the last term is positive, then we check the middle terms. If the last term is positive and the middle term is positive, the signs of the factors are positive. Okay? If the last term is positive and the middle term is negative, then the signs of the factors are negative. Remember, they're both the same. So if they're both the same, if the middle term is positive, they're both positive. If they're both the same and the middle term is negative, then they're both negative. Conversely now, if the last term is negative, then we know both the signs of the factors are different signs, okay? And then it tells us if the middle term is positive, the largest factor of the 2 is positive. If the middle term is negative, then the largest factor of the 2 is negative. So again, I'll use some different colors here. If the last term is negative, we gotta check the middle terms. If the last term is negative and the middle term is positive, the largest of the 2 is positive. If the last term is negative and the middle term is negative, then the largest factor is negative. And then last but not least, if the polynomial has 4 terms, we look to factor by grouping. That's all you do. We always do, obviously, before we do all of these, greatest common factor, but then you have the binomial, the trinomial, and the 4-term polynomial, okay? So let's try some binomials. So look for a greatest common factor, and you can take a 3x out of each one, and that'll leave x squared minus 3. Okay, how did I get that? I was able to get a 3x out of here, so I got to divide 3x out. I got to divide 3x out. When I take that and divide by 3x, I'm left with x squared. When I take that and divide by 3x, I'm left with that. Now, let me kind of clean up some stuff here. this x squared minus 3 is not a difference of squares. This is a perfect square, and this is not a perfect square, so this is done. That's just greatest common factor. Now, number 2, we're going to take a greatest common factor of a 4 out. Divide by 4, divide by 4, and 4x squared divided by 4 is x squared, minus 16 divided by 4 is 4. Now we have a greatest common factor, and now we have that difference of squares. Because this is a perfect square and that's a perfect square. And if we have a difference, and it's only with a difference, not with a plus sign, we can just do this. We can do x squared plus 0x minus 4, and the last term is negative. All right. And so let me get some room here. We got a 4. Clean up a little bit. We have a 4. That's 1 and 4, 2 and 2. And both the terms have to add to 0. So one's a positive, one's a negative. So I have x plus 2, x minus 2. So don't forget that 4 for the greatest common factor, because that's part of the answer. And there's your final answer. So there are 2 binomials, one with only a greatest common factor and one with a greatest common factor and then a difference of squares. All right, those are the only 2 binomial examples you're ever going to see. Okay, now our trinomials, we have 4. All right, number 1, look for greatest common factor. I have x squared plus 6x plus 8. There's no greatest common factor of all 3. So if the last term is positive, the middle term tells me that both my factors are positive. All right, and when I talk about both my factors, I take that 8 and I list the factors, 1 and 8, 2 and 4. So both of these are going to be positive. Both these are going to be positive. Which ones add to positive 6? There you go. X plus 2, x plus 4. You're done. Okay? Number 2. I'm going to change colors here. I want a greatest common factor out. It looks like I have a 2. So that 2 is part of our answer. Now, what do we have left? We have x squared left, minus 10x plus 21. How did I get that? When I divide that, leaves me x squared. 20 divided by 2 is 10. 42 divided by 2 is 21. So now I have to look at these. All right, I'm going to change some color here again. And I have the last term is positive and the middle term is negative. So the last term tells me both the signs of the factors are the same. The middle term tells me they're both negative. So I take that 21. I have 1 and 21 and 3 and 7. Those are my only factors. So the largest, so both of them are negative, right? The last term is positive, so they're both the same sign. And the middle term tells me they're both negative. These 2 add to negative 10. So I have that 2 times x minus 3, x minus 7. You're done. Okay? Then come to number 3. Look for a greatest common factor. I see a greatest common factor of 3. I'm going to divide 3 out of everything. And I'm left with 3 divided by 3 is 1, or x squared. 9 divided by 3 is 3, or 3x. And 54 divided by 3 is, I think, 18. Okay? Now, I take that 18, list its factors. 1 and 18, 2 and 9, 3 and 6. The last term is negative. That means the signs are going to be different signs. So these factors here are going to have different signs. One's going to be positive, one's going to be negative. And this tells me that the largest one is positive. So I give all the larger ones the positive sign. And which 2 add together get you that positive 3 in the middle, right there. So 3, x minus 3, x plus 6. You're done. Okay? Number 4, no greatest common factor. So I take 24 and I list the factors. 1 and 24, 2 and 12, 3 and 8, 4 and 6. The last term is negative. So they're both different signs. These 2 will have a different sign. These two will have a different sign, right? So I got to figure out which ones are those different signs. So let me get those numbers back up there. So if they're different signs, the largest one is going to be negative because that middle term is negative. Which two, when added together, give you that -5? These two down here. X plus 3, X minus 8. Pretty simple. All right, and there's our answer. All right, sorry about that. And now we have factor by grouping. Anytime you have 4 terms, we look to factor by grouping. So we're going to look at the first 2 and the last 2. All right, so what can I factor out of the first 2? An x. And that leaves 3x plus 1. What can I factor out of the last 2? I can factor out a 2. Now, this middle term is positive, so I'm going to factor out a positive 2. And that leaves 3x plus 1. It'll always have the same in here and in here. Remember, we talked about that last week. So now we go to the second phase. What can we factor out of this and this? What's the same in both of them? 3x plus 1. And that leaves x plus 2. And you're done. That's called factor by grouping. Okay? Over here, I'm going to do the same thing. I'm going to factor these two. I'm going to factor these two. Over in the front, I can take an x out. That leaves x plus 5. Now, in the last two, I'm going to take out a 2, but I'm going to take out a -2. So if I take out a -2 from that -2x, it leaves just x. If I take a -2 out of the -10, it leaves a +5. And again, notice, these are exactly the same. So what do I factor out of both of them? X plus 5, and that leaves x minus 2. You're done. This is our new last week. And some of you may say, oh, it's kind of hard. I'm not sure how it works. You know, we just got to keep practicing it. Just keep watching me do it or contact me because you will see a lot of this in the near future. Now we're going to simplify radicals, okay? So this is the radical sign. All right? So if we look at the radical sign and we look at, let's say, x squared and the square root of x, these are opposites of each other. Just like adding and subtraction undo each other, multiplying and division undoes each other, squaring something or taking the square root of something undoes it. These two undo each other, okay? So what we're doing, if you take this in your calculator, the square root of 4, you're going to get the number 2. What it means is it's looking for the number on the inside, and they want you to factor it. 4 becomes 2 times 2. And not only are we going to factor, we're going to do prime factor. We want it to factor into the prime numbers. Okay, so that brings out a couple things. How do we factor? That we'll practice that. And what are prime numbers? Prime numbers are larger than 1. Okay, so let's do this. Let's give me some room up here. Prime numbers. Are larger than 1 and only have 1 and itself as factors. Okay, so like the number 10, okay, when we factor it 1 and 10, 2 and 5, it has 1 in itself as factors, but it also has 2 and 5, so 10 is not prime. If we take the number 7, 7 only factors to 1 and 7, so that is a prime number. So we want only numbers that can be factored to 1 in itself. All right, the number 9 is 1 and 9, 3 times 3, so this is not prime. Okay, the number 11, 1 and 11, that's it. This is prime. Okay, so what we want to do is always look at, okay, taking the number on the inside, that 4, and breaking it down to its prime factors. And so there's only numbers, and you'll see it'll be more than 2 numbers. So, and we have really, this 4 can be rewritten as 2 times 2. So anytime you have a pair, the pair being multiplied undoes the radical. So it just becomes 2. So you can take a pair and turn it into one of the numbers on the outside of the radical. Inside it has to be 2 of them, okay? I'll give you an example with the square root of 16. 16 can be broken down to 2 times 8. And then we can break that down to 2 times 2 times 4. And then we can break that down to 2 times 2 times 2 times 2. Remember, we didn't stop here because 8 was not prime. We didn't stop here because 4 was not prime. Now all these are prime. These 4 numbers, when multiplied, give you 16. So really, the square root of 16 is equal to the square root of 2 times 2 times 2 times 2. And so what does that equal? Well, do the square root of 16 in your calculator. You should get 4. Okay? So watch how we do it mathematically with a paper and pencil. We go from here down to here. We have 1 pair, so we can take that out to 1, 2. We have another pair, we can take that out to another 2. And 2 times 2 is 4. Okay? Notice there's nothing left inside the radical. If there was something left inside the radical, we would leave it there. We'll talk about that in a little bit. So here, with 81, you can take 81, it's not divisible by 2, but it's divisible by 3 times 27. Then 3 times, and this can break down to 3 times 9. 9 is not prime, we talked about that. 3 times 3, that's these two, times, the 9 becomes 3 times 3. So the square root of 81 is really 3 times 3 times 3 times 3 on the inside. There's 1 pair, I can take out a 3. There's a pair, I can take out a 3. When I multiply this, I get 9. Square root of 9. All right? So let's practice ones that aren't perfect to a whole number. Like 2, on this one, the square root of 20 becomes 2 times 10. Keep that 2, and this becomes 2 times 5. 2, 2, and 5. If I were to multiply these 3 numbers, I'll get 20. They're all prime, so let's put them inside the radical. 2 times 2 times 5. Here's a pair. Take that out. That's on the outside. There's no pair with this, so it's left on the inside. So it's 2 times the square root of 5. That is a simplified radical. Notice nothing can be simplified more out of this, and we got a number on the outside. That's a simplified radical. Number 40, okay? 40 is 2 times 20. 20 is not prime, so we got to keep going. 2. This becomes 2 times 10. 10 is not prime, so that becomes 2 times 2 times 2 times 5. 2's and 5's. If I were to multiply these 4, I would get 40. It's ready, so put it in the radical. 2 times 2 times 2 times 5. This becomes, 1 pair comes out. These do not have a pair, so I can't do any with them but leave them inside. And what is 2 times 5? 10. So this becomes 2 times the square root of 10. That's a simplified radical, okay? Because we can't pull anything else out of the radical anymore, we're done. Let's try this one, the square root of 54. Oh, I don't need this. Let's do 54. That's 2 times 27. That's 2. 27 is not prime. That's 3 times 9. And then 9 can go again. 2 times 3 times 3 times 3. So if I multiply all 4 of these, I'll get 54. So let's put them in the radical. 2 times 3 times 3 times 3. There's no pair with the 2, so that has to stay. Here's a pair. Cross it off. Put it on the outside. There's no other pair with that. So what's left inside? 2 times 3. We got to multiply it. It becomes 6. And there's our answer. Okay? This is our new work, and we're going to practice this a lot. But notice we practice a lot of the factoring a lot over and over again because we're going to just keep doing it. So factoring, radicals, big